This is my first YouTube video. I'm gonna be explaining the calculus concepts for exam 2. I'm gonna first start with chapter 3.3 since it's the basics, which are the rules of the derivative. So let's start. Let's say first of all I have y is equals to... Now y and f of x are the same thing. So we can either say y is equals to this or f of x is equals to this. Okay, let's start with my first case. Let's say I have y or f of x is equals to 5. 5 here is a constant. It's on its own. It has no variable. The derivative of any constant, which is I can denote as y prime or f prime of x, is always equals to 0. So the derivative of any constant is always 0. My second case, let's say I have y is equals to 5x. Now, here I have my x is to the first power. Whenever I have x to the power of 1, my derivative is always going to be the coefficient. So my derivative here is going to be what? 5. So whenever I have x to the power of 1, my derivative is always going to be just the coefficient, what's outside. Okay, let's take my third case to be y is equals to x to the power of 5. Now, whenever I have x to the power of something, that's not 1, so I have two steps. First, what I'm gonna do is, so y prime is equals to, I'm gonna take the power, which is 5, multiplied by the coefficient, which is in this case 1, so 5 times 1, x to the power of, my second step is gonna be power minus 1, so 5 minus 1. So if I want to write it, I'm going to say first step is the power times the coefficient, and my second step is going to be the power minus 1. So my final answer is going to be here, y prime is equals to 5x to the power of 4. My fourth case, let's say I have y is equals to 4x to the power of 5. Now here nothing changes. I'm gonna solve normally. What I'm gonna do is the same thing as I did in the one before. So y prime is gonna give me coefficient, which is 4, times power, which is 5, x power minus 1, 5 minus 1. So my final answer is gonna be 5 times 4 is 20, x to the power of 4. Let's take another example. Let's say I have y is equals to x to the power of negative 3. Now here nothing changes as well. Even though my power is negative, I still apply the same formula. It's not really a formula, but it's the way you solve it. So y prime, I'm gonna take the power, which is negative 3, times the coefficient, which is 1. Negative 3 times 1, x to the power of power, negative 3 minus 1. I'm gonna end up with y prime is equals to negative 3x to the power of negative 4. Now this is correct, but if we want to get a positive power, what do? We take the x down. We leave the coefficient negative 3 up in the denominator over x to the power of 4. The power here becomes a negative. Let's take one more case. Let's say I have number 6. I have y is equals to radical 4 over 2x squared. It's the same thing. I'm gonna take radical 4 over 2, which is my coefficient, radical 4 over 2 times the power, which is 2, x to the power of power minus 1, so 2 minus 1. I'm gonna multiply these together. The 2 and 2 can cancel. I have radical 4x. Okay, now I have two cases where I cannot find the derivative unless I fix the equation. So my first case where I cannot find the derivative, so here the derivative cannot be found. I cannot find the derivative here unless I fix the issue. So here the derivative cannot be found. let's say my first case is when I have x in the denominator. So whenever I have a power in the denominator, I cannot derive. I'm gonna have to fix this problem. Let's take an example. Let's say I have y. Let's say I have y is equals to 5 over x to the power of 3. So, can I derive here? I cannot derive here because I have an x in the denominator. So to find my y prime, I'm gonna have to fix this problem. Now here it's still y. It's not y prime yet. I'm not finding the derivative. I'm just fixing the problem so I can be able to derive. What do I do here? Whenever I have an x in the denominator, I'm gonna take the x up to the numerator and its power is gonna become negative. And let's say here what am I gonna do? Y is equals to 5x to the power of negative 3. So the power switches sign when we take it up. Now we have our y. Do I have anything in the denominator? No. Can I solve for the derivative? Yes. So now we're gonna find y prime, which is like we said before, power times coefficient. This is the coefficient, this is the power. X to the power of power minus 1. So I'm gonna have y prime is equals to negative 15 x to the power of negative 4. Now, this is correct, but if I want to get a positive power, I'm gonna do negative 15. I'm gonna take x to the power of 4 down. So it's gonna become x to the power of positive 4 and not x to the power of negative 4. Now I have my second case when I cannot find the derivative when I have a root. Let's take an example so we can understand it better. Let's say I have y is equals to 7 x to the power of 5 to the third root. Now, here I cannot find the derivative since I have a root. Now, one rule I need to know whenever I have a root to help me fix the problem is, let's say, so this is an important rule, when I have radical x, n over a. So x to the power of n, and this is the root I have outside. It's always gonna be equals to x to the power of n over a. Or if we want to say it in an easier way, we can say x inside over outside. You know what I have inside, which is my n, over the outside, which is a. So let's apply this here. I have y, I'm still not finding the derivative yet, I'm only fixing it. 7 is the coefficient, I don't need anything with it. X, n over a. So this is my n, this is my a. So it's going to become x to the power of 5 over 3. Now I fixed the problem. Do I have a root? No. So now I can find the derivative. Let us find the derivative here. We solve it normally like we did before. The coefficient times the power here, which is 5 over 3, x to the power of 5 over 3 minus 1. Let's simplify this. It's going to become 35 over 3 x to the power of 2 over 3. This answer is acceptable, but let's, fix it more. So it's going to be 35 over 3. Now, I'm going to use the same rule to write it in a radical again. I'm going to use this rule. Oh, okay. Sorry. X inside over outside. So, what's my inside here? Let's look up. N over a. So here, what is my n? My n is 2. So then here, let's write it x to the power of 2 over 3. And I don't know if it's a slanted line, it's going to be a bit difficult to understand. So my n is 2 and my a is 3. So I'm going to do inside and outside like we said before. So radical x squared to the third root. So inside here over outside here. So now we did some basic derivative rules and we did two cases where I cannot find the derivative unless I fix the problem. Now let's solve a few examples. Let's say when I have derivatives that involve addition. Let's take an example. Addition and subtraction. They both go under the same case. Let's say I'm gonna put 1 for addition, 2 for subtraction. Let's say I have for addition y is equals to 12x to the power of 4 plus 5x to the power of 3. Now y is equals to 12x to the power of 4 plus minus 5x to the power of 3. So let's start solving the first one. It's going to be the exact same thing. I'm going to find the derivative of this first. So y prime is equals to, like we said before, coefficient times power minus 1, then plus, solve for the second one, coefficient times power x minus 1. Okay, now let's just solve normally. I'm gonna have 12 times 4 is 48, x to the power of 3 plus 15x squared. This is my derivative. I have no rules to apply, nothing. We're just gonna solve the derivative normally and just add them together. Now let's this one, it's the exact same thing, just with a negative sign. So 12 times 4, x to the power of 4 minus 1, minus 5 times 3, x to the power of 3 minus 1. I'm gonna simplify. 48x to the power of 3 minus 5x, sorry, minus 15x squared. So it's the same thing. I just solve normally for them. Okay, now we're gonna start the more complicated stuff, which are the product and the quotient rule. Let's start with the product rule. Product rule. What's the product rule and when do I use it? I use the product rule when I have two functions multiplied by each other. So this is a symbol of multiplication. Let's say, for example, u times v. Now, what's my formula? How do I solve the product rule? To find, let's say, y is equals to, my y prime is gonna be u prime v plus v prime u. So the derivative of u times the normal function v plus v prime, the derivative of v times the normal function of u. Let's take an example to understand it better. Let's say I have y is equals to x to the power of 3 into x squared plus 1. Now, I need these two functions are being multiplied by each other. Now to make things easier for myself, I'm gonna do a little table on the side. Okay, so this is my u, let's label them. This is my v. I'm gonna do here u is equals to, I'm gonna write my function of u, x to the power of 3, u prime is the derivative of u, coefficient times, and we should be able to do it quickly now, and then v is equals to x squared plus 1, my derivative is 2x. Okay, now I'm gonna apply the rule. So my y prime is gonna be equals to u prime, let's take u prime, which is 3x squared times u prime times v, what's my v? X squared plus 1, plus v prime, which is 2x, times u, my u is x to the power of 3. Now this is the derivative. Now all we need to do is simplify. So we're gonna take y prime is equals to 3x squared times x squared is gonna be 3x to the power of 4. When you have two powers multiplied by each other, you add the powers, plus 3x squared times 1 is gonna be 3x squared, plus 2x times x to the power of 3 is gonna give me 2x to the power of 4. Now let me continue and simplify further. Y prime is equals to, I'm gonna put like terms next to each other. We can do that or we can't. And for me, it works better this way. Plus 2x to the power of 4 plus 3x squared. So y prime, add like terms. 3 plus 2 is 5x to the power of 4 plus 3x squared. So this is my final answer. So the derivative of this, which is x to the power of 3 times x squared plus 1, is 5x to the power of 4 plus 3x squared. This is my derivative. Okay, Now my next complicated rule is gonna be the quotient rule. Now, the quotient rule, when do I use it? I use it when I have two functions being divided by each other. So I have u over v. Now, what's my formula for this? U over v is gonna be u prime v minus v prime u divided by v squared. Let's take an example so we can understand this better. Let's say I have y is equals to x squared plus 1 over x to the power of 3. Now, I need to find the derivative of this function. I'm gonna take the exact same thing I did in the question before. Let's take two different colors so we can differentiate between them. So this is gonna be my u, and this is gonna be my v. Now let's do the table like we did before. I'm gonna write u is equals to x squared plus 1, u prime is 2x. Then I'm gonna take my v is equals to x cubed. My v prime is gonna be 3x squared. Now let's just pay attention to one point here, is that when we're simplifying, we have to be careful that we are multiplying the correct order. U prime v minus v prime u. This is not the product rule, so we cannot switch them since subtraction is not commutative, so we have to stick to the same order. Let's start solving. I'm gonna go by the formula. Y prime is equals to u prime v, so 2x times x to the power of 3 minus v prime u, which is 3x squared into x squared plus 1 all over v squared. What's my v? X to the power of 3, so x to the power of 3 all squared. Now I'm gonna simplify. I'm gonna take my y prime is equals to 2x times x to the power of 3 is gonna give me 2x to the power of 4 minus. Now here, since I have a negative sign, I'm gonna open a bracket since I'm gonna distribute the negative later on. 3x squared times x squared is gonna give me 3x to the power of 4 plus, now we're not distributing the negative yet, we're just solving this. Right now, we are just solving for this one. We're not doing anything with the negative. Plus, and then we have 3x squared plus, times 1 is 3x squared. And then over x to the power of 3 all squared, which can be simplified as, here when I have power like this times a power, it's 3 times 2, which is going to give me x to the power of 6. Now, what am I going to do? I'm going to distribute the negative. So the 2x to the power of 4 is going to stay the same. Negative times positive is going to be negative 3x to the power of 4. The negative times positive is also negative 3x squared all over x to the power of 6. All over x to the power of 6. So now we're just gonna simplify. So y prime is equals to 2x to the power of 4 minus 3x to the power of 4 is negative x to the power of 4 minus 3x squared all over x to the power of 6. X to the power of 6. Now I can further simplify this. We have two ways of solving this question. I'll show you using the product rule and using just simplification. So here, what am I gonna do? I'm gonna take y prime. I'm gonna take negative x to the power of 4 negative x to the power of 4 over x to the power of 6 minus 3x squared over x to the power of 6. Now, why am I doing that? Because I need to fix the powers. So 4 minus 6, whenever I have two powers divided by each other, I subtract them. So it's going to be negative x to the power of 4 minus 6, which is negative 2, minus 3 stays the same, x squared over x to the power of 6, so x to the power of 2 minus 6, which is going to give me x to the power of negative 4. Another way we can rewrite this is like we said before, so negative x squared goes down, so 1 over x squared, so the negative cancels, minus 3. I'm gonna take 3 as it is, 3 over. Now x to the power of negative 4 goes down and becomes x to the power of 4. So my final answer is gonna be this. Y prime is equals to negative 1 over x squared minus 3 over x to the power of 4. You can leave it like this one, it's fine, but this is more preferable in my opinion. Okay, so I showed you the first way how to solve it using the quotient rule, for the sake of explaining the quotient rule. But there's another way I can solve this, only when it's possible. So what can I do here? Without going through all of the quotient rule. Did I say product rule before? I meant the quotient rule. So y prime, before y prime, I'm gonna simplify it. So I'm gonna take y is equals to, I'm gonna take the x to the power of 3 up. So it's gonna become a negative power. So x to the power of negative 3 into x squared plus 1. Now, after I do that, I'm gonna multiply, so it's still y, not y prime. I'm gonna multiply x to the power of negative 3 by x squared, and you distribute here the x to the power of negative 3. So x to the power of negative 3 times x squared is gonna be negative 3 minus 2, since I'm adding the powers. So negative 3 plus 2 is negative 1, so x to the power of negative 1. Then I'm gonna take x to the power of negative 3 times 1, which is gonna give me plus x to the power of negative 3. Now, I've fixed my equation. Now I will find the derivative. So I was not finding the derivative before, and now I'm gonna find it. So y prime, I'm gonna solve normal derivative, coefficient times power, x to the power of power minus 1 plus negative 3, which is power times coefficient, x to the power of negative 3 minus 1. You can just do it directly, and I'm just doing this for the people who do not understand it properly yet. So negative 1 x to the power of negative 2 minus 3x to the power of negative 4. See, we directly reached the result we reached here, and then we're gonna directly do y prime. What's this? Y prime is equals to negative 1 over x squared. I'm gonna take it down, minus 3 over x to the power of 4.